similarity. And we have for each query compound, we have defined similarity of training compounds using one of these kernel functions. Sorted based on the sorted list, we have predicted the toxicity using this formula of weighted average prediction. So we have selected prediction purpose, but as you can see, we have maximum 18 compounds in each data set. So maximum we can have 9 compounds in our source list. So there can be a maximum 9 compounds in the source. So, but in our algorithm allows us to use up to 10 compounds. The first kernel function is Gaussian kernel function, which is based on this expression. And X and Y are 2 vectors of length n. So one of them is the vector for the target, and another is the vector for the source. And here x1, x2, x3, these are the descriptor values. And this is the L2 norm between the 2 vectors of length n. So this is basically Euclidean distance between the 2 vectors. And finally, we apply this formula algorithm. And here we use a different kind of different values of, like, say 0.2. 0.25, 0.5, 0.75, 1, uh, 1.25, and so on. But this is to be optimized. Here also we use a variable number to be optimized. And similarity. And after initial division into the source and the based on this formula, that is original descriptor value divided minus mean of the training set descriptor values divided by standard deviation source compound. This is for the descriptor value as for carrying distance values, and then scale between 0 and then we use different. And once we have the predictions, this one, weighted average prediction, then we apply. We can see from here, as I've already shown in case of validating QSR model, so we compare the observed values with the predicted values, and we take the mean of the training set response as our reference. So this formula is for Q square F1 or R square F8, and the value should be more than 0.6. In another version, that is Q square F2, we use the mean of the test set compounds as the reference. So everything is same, only we change the reference. So this is called Q square F2. Then also we can use our root mean square error of prediction, that is sum of residuals between the observed and predicted value for the test or the target compounds, and this is divided the number and you have to take square root of that. And obviously the root mean square error of prediction should be low, and Q square F1 and Q square F2 values should be a high value. Now after we get to see the classification ability of the model. Although we are getting the quantity value, but sometimes it may be important for us to check the prediction based on the binary classification. And for this, we can use the training set response mean as the threshold, and we can classify all the predicted values either highly toxic or less toxic based on that. Any predicted value higher than the mean of the training set toxicity value, mean toxicity value, is considered higher toxic, and any toxicity value lower than value may be considered as the lower toxic. And based on the quantity prediction, we can use whether the predicted toxicity is the higher toxic or lower toxic, and then we can use the experimental values for comparison, and we can derive these true positive, true negative, false positive, and false negative in the usual manner. And then we can sensitivity specific means Matthews correlation. The quantitative predictions are so important for predictions that we are getting, and because it is more important that toxic and non-toxic. So it may be important operation where the predictions may not be required, but if the Q-score F1 very high, but the one can use this. We have developed a tool, Java, that is available for free of cost for data in Excel form. So here the source and target data, which we call here training format. And user has to provide the Gaussian kernel and gamma and number of similar fuse and distance. We have used sigma and gamma values as 1 each. We have generated 2 output files, logical activity, and that is for sorting of the program. When we use it wants the thing set name, it wants the test set name, it asks for the gamma value, it asks for the sigma value, and so on. It asks for the threshold similarity. One you can give 0 also, that is no threshold, etc. So this the program output looks like this. This is the sorted activity values for each query compound. Say this is the query compound ID for 17, and these are the sorted toxicity value of the source compound. This is let's say this is for Euclidean distance, this is for the Gaussian kernel, this is for Laplacian kernel, and again for another identifier, say number 5. These are the sorted values of query compounds based on similarity. This is based on Euclidean distance. This is based on Gaussian kernel function, and this is based on Laplacian. This is the biological activity values, so predicted value. These are the identity and so on. So this is the prediction Gaussian kernel approach. This is based on also you can have your metrics like Q-score F1, Q-score F2, and RMSE calculated. Here you can see 0.63, 0.62, and so on. So you are getting in the same file the predictions value and all the metric values in the Excel form. So you are getting the Excel in the output, who you can use for your purpose. So we have used three different data sets.